Alright, so for number 9, for starters, we want to go ahead and draw a line underneath. And then we're going to rewrite 1 minus secant x and 1 plus secant x as 1 minus 1 over cosine and 1 plus 1 over cosine. And so then our next line of work is going to look like 1 minus 1 over cosine over 1 plus 1 over cosine, and now we're going to multiply by a cosine x over cosine x in order to clear the complex fraction. And then our final line of work is just going to be the answer for this one. Which is going to be the result then of the distributive property. I'll put a dot here between the fractions to show the multiplication. Okay, then for the next one, we can be working on the left-hand side and the right-hand side for this one. For the right-hand side, we can rewrite tangent as sine over cosine, so that we end up with sine x. Now I'm going to leave myself a little bit of space in front of the sine x, anticipating that I have a common denominator coming. Notice that I am now creating on the right-hand side a denominator of cosine where I had the tangent, which means that the sine x also needs to have a denominator of cosine. And so to make that happen, I'm going to just take its natural denominator of 1 and now multiply this fraction by a cosine x over cosine x. Sorry, this is a little squished. And so now we have one big fraction with a cosine denominator. And for my numerator, I have a cosine x, sine x, and notice that has a GCF where I can factor out that sine x. And so when I factor out that sine x there, I'm going to end up with a sine x cosine x plus 1. And then of course I still have, and then I still have that denominator there of of cosine. Alright, then what about the left-hand side? Well, for the left-hand side, I can rewrite the cotangent as a cosine over sine. So I'm going to start by taking the original fraction and copy the numerator as is. The denominator I'm going to rewrite as a cosine over sine. And now I've created a complex fraction. So to clear the complex fraction, I'm going to multiply by a sine over sine. Now functionally what I'm doing is multiplying by 1, right? Because any expression, you can only ever multiply it by 1. The denominator of this pink fraction here is really a sine x, or you can view it as a sine x over 1, if that helps you structurally to even write a analogous complex fraction. So now the sine x here is going to cancel with that sine x there, and so for your next line of work, you have, and keep it factored because this is going to then match the right-hand side, you have the sine x times cosine x plus 1. And then your denominator now is simply cosine x, and so your left-hand side is equal to the right-hand side. So this is what it looks like to work on both hand sides. Notice that if you do work on both the left and the right-hand side simultaneously, your last step on each, for each side, your last step, here's the last step on the left, on the right-hand side, and then your last step on the left-hand side, they both need to have the same last step if you're going to work from both sides. All right, now for our last problem here, we actually have a difference of cubes. So let me quickly review difference of cubes for you. If you have the polynomial, here, let me try this, a cubed minus b cubed, then that is going to factor into a minus b times a squared plus ab plus b squared. So just review your sum and difference of cubes formulas. You should have learned those in either intermediate algebra or college algebra. In this case, we have a difference of cubes, so we're going to factor that numerator to look like that. All right, let me scroll up though, get a little bit more space. Oh, that's as far as I can go. Okay, so now I'm going to draw, for my left-hand side, I'm going to factor, and when I factor, I get a 1 minus tan t Sorry, let me try this again. I needed a little bit more space here on the left-hand side. 1 minus tan t times, here's the numerator. Let me start way over here. This is the a minus b, so that would be 1 minus tan t, which is nice because that's going to cancel with the 1 minus tan t in the denominator. So 1 minus tan t, and then times 1 plus tan t plus tan t squared. This second term here, the tan t, is really a product of 1 and tan t. So 1 squared is 1, plus 1 times tan t, which is just tan t, and then plus tan t squared. And so we see the 1 minus t is going to cancel with the 1 minus t. Now that leaves us then with, in the numerator only, we have a 1 plus tan squared. We can rearrange that. Plus tan. And now you can see how this is lining up really nicely with the right-hand side, where the 1 plus tan squared is going to get replaced then with a secant squared. And then the tan t is going to stay as it is. And that's it. That's the last of the proofs.